Okay, for number 16, they're asking to like sketch the graph. And they tell me the graph, it's figure 20, page 60. And I'm gonna say, it's not a bad looking graph, but you may describe, you wanna do a different graph than I'm doing. But this is the graph of y equals x to the 5 halves, which is really x, because 2 goes into 5 two times, and with what's left over is a half, so it's root x. All right? So I'm seeing the picture of it. All right? The picture is what they're given over here. What they go on to say on the interval between 0 and 6. And I do see that, and it's graphed out. I'm not going to put the numbers down for you. You can see those. You can blow this thing up if you like to get a better idea. All right? Then it says use the sketch to justify the inequality for h being a positive number. And I'm looking at the graph here, and I'm looking at it, and I'm seeing something, and I know what f prime of 4 is. Let me write this over here for you. I know that's a limit problem, by the way. All right, so I know this is like over here somewhere. All right, so I got to think about what they're doing over here. And what they're doing is, if h is a positive number, and they're adding it, this is going to be 4 f of 4. That's what the point is. If h is positive, I go to the right, this would be 4 plus h, comma, f of 4 plus h. Let me get my eraser out. I'm going to erase this biz over here. Again, they said h is positive. I can remember that. And then if you went to the left, like over here somewhere, and someone says, what's this point over here? Oh, I would say 4 minus h, f, and again, h is some positive number. If you take it, you're going to be below the 4, by the way, and f of 4 minus h. And what I'm going to do, just looking at the picture, I'm seeing the slopes to these things as being one being bigger than the other. So to the right side, the slope is bigger. So I'm going to write the slopes down to the secant lines. So let's do the right-hand secant. And I know there's a derivative over here. There's a slope there. But this slope here is bigger, and this slope here is less than it. Let's write that down. So I'm going to say f prime at 4 would be less than or equal to, depending where h is. Like if h comes in really close, it would be the same thing. And let's write it down. It's going to be a difference quotient now. What's that going to be? F of, we're taking this point, subtracting this one. F of 4 plus h minus f of 4. What goes on bottom? 4 plus h minus 4 would just be h. So I want to claim we've got this part of it done. Let's do the lower guy. And what's that going to be? Well, what do you get there? It's slope between this point and that point. Let's write that down. What's it going to be? Let's see, f of 4 minus, I'm doing upper minus lower, f of 4 minus h. And then it's going to be, upper's 4 minus a minus h, which is just h. So I got this, and that's what they wanted to show. And you get that by looking at the picture and realizing the picture is an increasing function. Its derivatives are getting bigger as we move left to right on that interval. All right? Let's take a look at next up. They want me to compute this to 4 decimal places. And the way to do that, be honest with you, I'd use a computer to do it. I wouldn't be doing these by hand computation, but I would be taking a really small h number. So remember what we did in the past. We would take h's, and by the way, h is greater than 0. All right? H is greater than 0. So what's a good number to pick? Like 0.1. That's a small number. Then you do like 0.01, 0.001. And I'm a big fan of doing things 3 times. And I think to myself, I know where h is going. It's going towards 0. But then what you have to do is you have to compute these guys over here. Is that work? It is work. You can do it on a computer, though. And if you do it on a computer, you should be getting numbers. I chose a pretty small number over here. You should be getting numbers on the left that are going towards like 19.9999, and on the right you should be getting numbers like 20 point blah 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 blah. You see that there. And I actually did a computation on a computer, and looking at this over here, I'm going to say, looking at it, the number that's between those two, looking at it, I'd say it's roughly 20. That's what I'd say. All right. Now, is it exactly 20? I'm not saying it is or is not. I'm just saying they asked me to approximate it, and 20 seems like a reasonable thing. If you still need help with the computation, we spent a lot of time in prior homework sets using Sage to do this over here, and I'm hoping you're actually familiar with that at this point, or at least using a calculator to do the computation. All right, the other thing is, use a graphic utility to plot f and the tangent line, and the bottom line is, how do you plot a tangent line? It's at a point. What's the point going to be? It's going to be at the point 4, f of 4, and yes, I did use a computer to plot it. And then what do you do over here? Well, I got to compute the point, don't I? And what's it going to be? If you remember, y was equal to x squared root x. So I can write this down. It's going to be 4. What's f of 4? Well, it's going to be 16 times 2, which is 32. So if you were to write this down, what would you get? Y minus y1. What's y1? 32 equals the slope. We believe the slope is somewhere around 20. And what do you get over here? X minus 4. Let me rewrite a little tiny bit, and you can get 20x. That's going to be minus 80 plus 32. And if you did this, it's going to be y equals, let's see, 20x. That's a pretty steep slope, isn't it? And then, minus 80 plus 32 is minus 48. All right? What am I expecting? That this line intersects the y-axis at minus 48. And has a slope, approximately 20. And what I do, I use a computer to do that, and I do recommend that you also use your computer to do that. All right? It really kind of got tough to do otherwise. Thank you.